All right, today we're pulling back the curtain on something that pretty much dictates the speed of, well, everything in modern manufacturing. We're talking from the phone in your hand to the planes in the sky. It's this hidden metric called the material removal rate, and it's basically manufacturing's secret speedometer. So let me ask you this. What do you think is the single most important number in all of manufacturing? Now, you might be thinking profit margins, maybe production volume. Nope. It's something way more fundamental, a measure of just raw, pure efficiency. And that number is the material removal rate, or what folks in the industry just call MRR. At its core, it's actually pretty simple. It's all about how much material you can carve away from a block of something, a workpiece, in a certain amount of time. Think of it in, say, cubic millimeters per minute. The bottom line is, a higher MRR means you're making things faster. It means greater productivity. Simple as that.
But here's the thing. This speed isn't just random. You can't just floor it. It's a super carefully controlled process. You see, engineers have this set of levers they can pull to dial the MRR up or down. And if you want to understand modern manufacturing, you have to understand these levers.
Okay, so here are what we call the big three levers. First up is cutting speed. Pretty straightforward. That's just how fast the tool is zipping across the surface of the material. Then you've got feed rate. This is all about how aggressively you're feeding that tool into the material. And last but not least, depth of cut, which is exactly what it sounds like, how deep you're cutting with each pass. You tweak any one of these, and boom, your MRR changes. Now, what's really fascinating is that these levers, they aren't all created equal. Take this recent study from 2025 by Wu Chenwo and their team. They were looking at machining mild steel, that really common all-purpose steel, and they found that out of all the things they could change, cranking up the feed rate had the absolute biggest impact on boosting the MRR. It just goes to show you, every single material has its own unique recipe for speed. But you know how it is. Just when we think we've mastered the rules of traditional cutting, technology comes along and completely changes the game. Those old physical levers we just talked about, they're starting to get replaced by something a little more electric. And that brings us to something called wire electrical discharge machining, or WEDM. Get this, instead of a physical tool touching the material, WEDM uses a super thin wire and a series of incredibly powerful electrical sparks to literally vaporize the material away. There's no physical contact, no cutting force. In this process, it is an absolute game changer, especially when you need to cut crazy hard materials or make these really intricate shapes that you just can't do the old-fashioned way. This comparison really shows you the shift, right? With traditional machining, you're tweaking physical things, speed, feed, depth. But with advanced WEDM, your levers are totally different. They're electrical. You're adjusting things like pulse duration and peak current. Now, this gives you unbelievable precision, but it also means the whole science of controlling the material removal rate just got a lot more complex. Okay, so whether we're talking about old-school physical force or new-school electrical pulses, the goal is always just to remove material faster, right? Well, not exactly. And this is where we really get to the heart of the issue, what I like to call the ultimate balancing act in manufacturing. I mean, think about it. If a higher MRR equals more productivity and less time on the machine, then why on earth don't we just max everything out? Crank all the dials to 11 and just go as fast as humanly possible.
Yeah, because there is always a trade-off. I mean, look at this. On the one hand, sure, you get high productivity, you get faster cycles, but the consequences can be brutal. You push the machine that hard, you're going to get a ton of tool wear, which means you're constantly replacing expensive parts. And even worse, the quality of what you're making just tanks. You get rough surfaces, inaccurate dimensions, so you end up making things really fast, but also really badly and really expensively.
And that right there brings us to the real goal for any modern engineer. It's not about finding the absolute maximum speed. No, it's about finding that perfect, elusive sweet spot. This, my friends, is the science of optimization. And check out this quote from a 2025 study by Ozlu, Ulas, and Kara. This is the key. They found that by optimizing, not just maximizing, the speed and feed rate, they could actually get the best of both worlds. They improved the material removal rate, while at the same time reducing cutting forces and tool wear. I mean, that is literally the holy grail of manufacturing. And really, that is the #1 takeaway here. The goal isn't the maximum MRR, it's the optimal MRR. It's finding that magical point where you're getting the absolute highest productivity you can, but without sacrificing the quality of the part or just burning through your tools like there's no tomorrow. It's that perfect harmony of speed, quality, and cost. Now, I know this might sound like some super technical detail that only engineers in a factory care about, but trust me, this quest for the optimal MRR actually impacts every single one of us every single day. Let's break down how.
Okay, so when a factory optimizes its MRR, it means they can make things faster and way more efficiently. That efficiency, it leads directly to lower manufacturing costs, which, you guessed it, means lower prices for you and me. And because optimization is all about balancing speed with quality, the parts and pieces that make up our world just get better and more precise. The engine in your car runs a little smoother, a surgical implant fits perfectly, all because of this obsessive, constant search for that perfect balance.
So, that brings me to one final thought to leave you with. We live in an age of AI and smart manufacturing where machines can literally monitor and adjust their own performance on the fly, in real time. So the big question is, as our machines get smarter and smarter, will that perfect, optimal removal rate, will it finally be within our grasp for every single thing we make? I guess only time will tell.